Hello everyone, I am Kaustad Datta, branch CAC, USN 1VE23CS082, semester 2nd, section BMW. So today's video is going to be on the subject Applied Chemistry for CAC stream, subject code BCHES102, topic corrosion. So first of all, I would like to welcome you all to my presentation. As you all know, corrosion is a silent but destructive process that affects metal. It occurs when metal is exposed to an electrolyte and becomes a cathode and anode. In this presentation, we will explore the definition, types, cause, effect, prevention, and control methods of corrosion along with real life case studies. So let's dive in. Definition of corrosion. Corrosion can be defined as the destruction or deterioration or loss of metal or alloys by the surrounding environment through chemical or electrochemical reactions. Chemical reactions. During corrosion, metal atoms lose electrons, leading to the release of metal ions. This process involves complex chemical reactions and can be accelerated by factors such as moisture and temperature. Fundamentals of corrosion. Corrosion is a natural process that converts a refined metal into a more chemically stable form. In corrosion, the metal acts as anode and cathode in an electrochemical cell. Corrosion may occur either in a dry environment or in aqueous medium. The former is called dry corrosion and the latter is called wet corrosion. So let's talk about dry corrosion. Dry corrosion is also called chemical corrosion. So dry corrosion involves the direct attack of metal by dry gases, mainly through chemical reactions. It occurs by directly attack of atmospheric gases such as oxygen, hydrogen, sulfide, halogens, and sulfur dioxide on the metal forming oxide layer. Example: the attack of dry air or oxygen on a metal to form an oxide layer over the surface. The other one is wet corrosion, also known as electrochemical corrosion. So, in wet corrosion involves reactions in aqueous solution medium. The conducting surface of the metal undergoes an electrochemical reaction with the moisture and oxygen in atmosphere. Example: the rusting of iron. Wet corrosion is explained on the basis of electrochemical theory. Types of corrosion. So basically there are three types of corrosion: galvanic corrosion, pitting corrosion, crevice corrosion. So galvanic corrosion is when two metals having different electrode potentials are in contact with each other in the presence of electrolyte. One metal acts as cathode whereas the other acts as anode. This leads to an electrochemical reaction, as a result of which the anode is dissolved into the electrolyte. Pitting corrosion. This type of corrosion is observed when dust particles or oil drops deposited over the metal surface. Pitting corrosion is due to metal surface is not homogeneous, external environment is not homogeneous, etc. Crevice corrosion. Crevice corrosion is a localized attack on the metal surface at or immediately adjacent to the gap or crevice between two joining surfaces when exposed to a stagnant electrolyte. So let's talk about the causes of corrosion. So the basic cause of corrosion is moisture, oxygen, and salt presence. The moisture. Water is one of the main culprits in corrosion. It provides conducive environment for chemical reactions to occur, accelerating the corrosion process. Oxygen. The presence of oxygen is crucial for the corrosion of most metals. It reacts with metal atom, initiating the corrosion process by forming metal oxide. Salt. Salt, especially in the form of salty water or salt laden air, significantly enhances corrosion due to its corrosive effect on metal. Effects of corrosion. The corrosion affects the structural integrity of the metal. Corrosion can compromise the structural integrity of building, bridges, and other infrastructures, leading to potential failure and safety hazards. Economic impact. The economic impact of corrosion is substantial, leading to costly repairs, downtime, and replacement of metal assets. Implementing effective corrosion prevention measures can result in significant cost saving, etc. Environmental concerns. Corrosion not only affects the structural integrity of metal but also has environmental implications. The release of metal ions and pollutants due to corrosion can impact ecosystem and human health. Prevention and control methods. Protective coating. Corrosion is prevented by the application of protective coating on the surface of metal. Thereby, the metal surface is isolated from the corrosive environment. Important types of protective coating are metal coating and inorganic coating. Metal coating. The process of coating base metal with a layer of protective metal is known as metal coating. First is anodic coating and second is cathodic coating. The other type of coating is inorganic coating. In this coating, the coating are produced at the surface of metal by chemical or electrochemical reactions. Example, anodizing and phosphating. Cathodic protection. Cathodic protection is the technique of offering protection to a specimen against corrosion by providing electrons from an external surface. There are two important methods of cathodic protection: sacrificial anode method, impressed current or voltage method. So let's talk about sacrificial anode method. It involves the use of a metal which is anodic to the specimen. In this method, the metallic structure to be protected is connected to a more anodic metal using a metallic wire. More active metal gas corrode, while the parent metallic structure is protected from corrosion. Design and material selection. Selecting corrosion resistant materials such as stainless steel or alloys can greatly reduce the susceptibility of structures or equipment to corrosion. So let's talk about some case studies on corrosion. Infrastructure. The impact of electrochemical corrosion on critical infrastructure such as bridges, pipelines, and building can be catastrophic. Marine corrosion. An analysis of corrosion in marine environment, exploring the challenges and solutions for protecting ships and offshore structures. Automotive corrosion. A examination of corrosion in the automotive industry, discussing the effects of weather, road salt, and design factors on vehicle deterioration. Types of corrosion testing. Corrosion testing encompasses different methods to assess the corrosion resistance of material and structure. Some common types of corrosion testing includes accelerated corrosion testing, salt spray testing, electrochemical testing, immersion testing, and cyclic corrosion testing. So now it's time to conclude the video. So in conclusion, I would like to say corrosion is a pervasive threat to metal assets, but with effective prevention and proactive measures, its detrimental effects can be mitigated by understanding the mechanism of corrosion and embracing innovative prevention techniques. We can ensure the longevity and sustainability of metal surfaces. So I would like to thank you all for being with me to the end of this video. If you like the content, then do like the video and please subscribe to my channel for more such informative content. Thank you.